Hello, everyone, and welcome to Getting Started with Rust Basics. I love that introduction video. It gets me every single time we do it. But my name is Korey, and I'm joined by...
My name is Chris Noring. I'm joining you from London, UK. So yeah, great to be here, Korey.
Great to be here as well. I am super happy to be talking about Rust Basics. I think a lot of people that have a lot of hype around it, Rust, and some excitement around it. So hopefully we could, in this presentation, show you why people are so excited about it. I would love to know in the audience here, one, kind of where you're joining from, because I'm always just like amazed by how sometimes global this audience is. So let us know where you are joining from in the chat, as well as if you have any other programming knowledge, like you come from JavaScript or C# or Python. Let us know that as well, so that we can, we'll talk only about Rust here, but it's always great to see where other people are coming from, because we'll probably have different code examples and different background there. I don't think anyone's like a Rust native developer. Like, I don't think anyone starts with Rust, but maybe you do. I don't know. So yeah, I see some Go. That's good. Welcome, Eric. We got C++, natural fit, I think. And Harold from Stockholm. Hello. Very close, hopefully, to where I am. Oh, and we have this now. I love it. Python, JavaScript combo. That's me as well. Bit of JS, bit of Go. Cool. So we got a good mix of locations and languages. So that's super nice to see. Today, we're going to talk about Rust Basics. And I'm going to start. I heard the best way to start with any sort of talk is to start with a story. So we're going to have story time. But this won't be any story. This is a love story, but a Rust love story. So very specifically about Rust. The story goes like this, and let us know if you've heard this story before. You probably have a developer friend. Let's say her name is Eve. And she, maybe you're around the lunch table, or maybe the digital lunch table, like on Teams channel. I don't know. Everyone's kind of working hybrid these days. And she says, hey, have you heard about Rust? And your response might be something like this. Yeah, maybe you've heard of it. Maybe you don't want to say that you've heard of it because you don't know exactly what it's all about. So you just go, yeah, Rust. I've heard some things about it, but I'm not exactly sure what's going on there. And, maybe her response is, well, Rust is the most loved programming language. Stack Overflow says it's years and years of Rust experience. Every programmer is loving the Rust development that they're using. And you might be like, okay, that's a good start. But I'm still not sure why people love Rust. You just kind of say that people love Rust, and that's it. So then, she says, it's the best. It has things like type safety, data race free, memory safe. It's has minimal runtime. It has zero cost abstraction, which who doesn't love zero cost abstraction, right, Chris? Like, who doesn't love it?
Yep.
So you've got all these terms, and you're probably, if you're very new to systems programming, which like it seems like some are. Let's see, we have some Python developers. We got some Java Clojure. So systems programming is quite new, maybe, and some of these terms aren't relevant to you. So you're probably hearing all of these terms thrown out at you, and you still might be confused. So you go to this Rust website, rustlang.org, and it says, this is a language for empowering everyone to build reliable and efficient software. And who does not love building reliable and efficient software, right? So it's still really pretty good branding, good marketing from the Rust team. But you still might not know what all this means, right? How we're building reliable, efficient software with Rust. And if it's for everyone, how do I not know what I'm going to do or how to work with it? So if that's your story, if you've felt these feelings before, welcome. This is what this talk is really going to be about. Some of the elbow cough, exactly. Never heard. Might be you. I don't know. um, some of the terms and things around Rust and what makes Rust great. We have a few different learning goals here. So we're going to understand what makes Rust great. We're going to understand what great things we can make with Rust and how can you actually get started making the great things with Rust. So very simple things to do, but we'll go into deep about how things are going there. We'll have some code examples throughout this presentation, but this won't necessarily be a hands-on workshop. So if you want to get hands-on with Rust, I think is also a great way to start learning with Rust. We have this Microsoft Learn module here, and I'll get that into the comments. And basically, you can really get started with working with Rust. It gives you some understandings of some of the concepts we might not touch here, like making your first function and things like that. So all of that will be available there. But again, we're going to talk about some of the great things with Rust so that you can get really inspired and have some confidence when you're moving on with working with Rust. So first, the great things about Rust. And this is going to be according to Chris and Korey. Chris, I don't think we're going to do anything like controversial here. I mean, hopefully most people agree with this, but would you say we're doing anything out of the normal, or we're going to talk about things that maybe people disagree with?
I think where we're coming from here is that, I think both you and me have been developers for quite a few years, right? And so the perspective we're coming at is like, we know other languages, right? I think Korey, you mentioned JavaScript, you mentioned Python. Myself, I've, done .NET, various other tech stacks as well, Golang and so on. But the way we're approaching things is, I think, like all developers, right? We want to know what is the ecosystem like? What tools are out there? What things are we used to existing for us to even contemplate moving to Rust, right? And I think that's the angle we're hitting. Am I right?
Yeah, I think so. And I'm like I said, everyone comes with their, I don't know, I wouldn't say baggage, but their own collection of things from working with languages. So I see we have a Pascal programmer. I see that's pretty rare. So I'm glad you're joining us. Like everyone's coming from all of these different perspectives to learn about Rust, which I think is what makes it so exciting for me, at least, to even be able to teach some of this stuff. So the first thing we'll talk about when we're talking about what makes Rust great, I think, is kind of Rust's killer feature, which, although I hate saying that because it's kind of graphic, but it's like main selling point, right? What gets people through the doors, gets people really excited about things. And it's also, I think, very important to understand when you're working with Rust early on, because then that's a good foundation. So it's the actual ownership model that Rust uses. And first, I want to talk about actually how it relates to memory management. And memory management might be some new concept to you if you're not doing any sort of systems programming before. I'll tell you why that's the case, maybe why you haven't thought about this before. But I like to say there's like two different places that memory goes, and anything that you do in your code, whether it's a function, a variable, it takes up memory. So you have to manage it in some type of way. And there's two places that memory kind of handles. It's in stack and it's in heap. So stack, and I have these two pancake examples. I want to be global for you, Chris, and I put the Swedish pancakes as well as the American pancakes, so the traditional pancakes, I guess. So everyone knows that's the flatter pancakes are the Swedish pancakes. But that is a good analogy for how memory is managed there. So it stacks on one another. So it's first in, so it just kind of builds on top of each other as far as the way the program works, and it stores the variables in order. And then also, when you want to take things out of memory, which we'll also talk about, it's last in, first out. So, I mean, maybe you would do this, but like you don't take, when you eat pancake, you only take from the top, like you don't go in the middle and grab a pancake. So in the same way, that's how memory sort of manages it in your program. What's nice about it is there's a known size at compile time, because again, we already know we've already allocated the memory for that. And it makes it faster to store and retrieve that memory throughout your program. So it's a quite efficient way for managing memory. The other alternative is heap. And I love this analogy. I wish I could say I've done this myself, or I can take complete credit of all this, but it's actually doing with a restaurant. So you can kind of think of, if you go to a restaurant, right, there's like seats allocated everywhere, tables, and some of them are full, some of them are not. And you go, party of two, Chris and I were going to a restaurant together, going to talk about Rust, of course. and then the waitress like goes around. The hostess finds like a table for us in the restaurant. So there's memory locations or spots there. And in the same way, a heap is a request for a certain amount of space actually inside the stack. So they have the hostess kind of acts as a pointer, or in this case, in the heap memory, returns a pointer where the space is, and then your memory, that's where the memory is stored. It's used when things aren't like when the size is unknown, so at compile time. So we'll look at the actual code examples of this to give you a better understanding, but that's kind of how the stack and heap will work out for memory management.
So
There's
Korey, just a short
yeah
I just had a short comment on this, right? Because it's interesting, right? When you're a Rust developer, you're starting out, and the memory management is a thing that you kind of need to grok, that you need to understand early, because it is, I'm not going to lie here, it is a bit of a curve to get past to understand how it works. But once you understand how it works, it doesn't get more complicated. It's like, it's like an upward hill, right? Well, once you've conquered it, it doesn't get higher. Am I right in that kind of observation? Or
yeah, I mean, like a pancake stack, you really you can only get so high, and then
yeah.
after that you can enjoy your pancakes, I guess. So yeah, no, that's true. That's why I think I really want to start out with this, because we're going to do our best here to explain, but once you get your hands into it and understanding it as well, again, I think this is very foundational knowledge to working with Rust for sure. So there's different approaches to memory management. There's garbage collection, which I think, looking at some of the examples that we have here, so we have also like a Python, JavaScript, the rest of TI Basic as well. I'm not actually even familiar with TI Basic, but that's cool. But if you look at some of the backgrounds of everyone here, maybe you probably fall in working with languages that are garbage collected. So they actually do all this memory management automatically. So most non-system languages, and you don't have to think about it. It does then cost time as far as performance, but as a programmer, it's like life is good, life is easy in regards to that. But we also have this manual approach, which is mainly like C language, for example, where programmers are responsible for managing the memory. So they can actually, when they're not using it or need to return the memory, if you will, they have to actually manage that themselves. And that's difficult. We'll talk about when that's difficult, what the problems are with that. But it's difficult. I mean, it's possible. But if you've ever tried to learn these languages, that's probably a huge learning curve for yourself. And then the last one is the Rust way. So we talked about the ownership model, which just follows a set of rules, which I'll show later on. And it has a thing called borrow checker that kind of checks all these things for you. So you aren't really breaking the memory, the rules that you might have to do in a manual approach, but it's doing all these things. So it's managing it and offering the garbage collector as well. Buffer overflow central. Yep. Feel your pain, Travis. Anything on this, Chris?
No, I think you kind of covered it, right? We have the garbage collection part. We have the fact that we need to count all these references when it comes to Rust, and thanks to the ownership model, there's a way for it to do that, right? And the fact that we have different owners and there could only be one owner, that kind of helps with our inner mental model, right? To say like, okay, if I have one owner, the thing I think grokked for me is understanding when am I leaving over ownership and when do you only borrow it, right? So, and I think you're going to talk about that more closely, Korey, but so that's one of the fundamentals of like, okay, if there's only one owner, there's only one person who can hold this book at one time. What does it mean, when I give this book over, or am I giving you like a copy of the book, or am I giving you like a reference to the book, right? So yeah, I'm looking forward to hearing you explain this more, and you're for sure making me hungry, right? All those stacks of pancakes.
Yeah, this is it. This is bad timing for our time zone, but some people, wherever you are, it could be morning time. Yeah, but memory management is a big deal, right? It's not just some kind of nerd topic that we're just geeking out on here. If we talk about like actual security bugs or security flaws, like our lovely employer Microsoft has even openly said that like 70% of all the security bugs that mostly happen in the OS is memory safety issues. So it's actually using or having programs that need to manually manage their memory that like they just haven't done it correctly. And it's again super hard to do sometimes. So if you look at the future of Rust development, we see a lot of investment around that. And even not only Microsoft, like companies like Mozilla have also openly said like this is like a key issue that we have seen for security issues. And if we have a language like Rust that can do this for us or manage it better, it's actually going to very much improve the quality of our software. Do you have a comment, Chris?
Yeah, I was just thinking about Twitter lately. Our Azure CTO, Mark Rusinovich, actually said, like, we should really be investing new projects into Rust and rather forego languages such as C++, because, with Rust, we have the memory management, we got the tooling chain and everything else, right? So just to add on what you were saying there, Korey, about memory safety, I mean, that's a huge deal with Rust. I mean, if I don't have to have 70% of all those security issues, like I'm in, you know what I mean?
Yeah, and I think it's like the proof of why people are embracing Rust so much. Like, I mean, Chris and I, we've both been around this like scene for some time, and there's always like this like hipster, cool. I learned this language immediately because of like all the popular things, and in some cases there's some substance behind it, and in some cases it's just like what is popping on Twitter. But in this case, Rust is like I think providing both, the excitement around it, but also a lot of the substance in regards to actually working with it and providing and solving some real issues. So in terms of actually the code and what we look at here, these are two kind of simple Rust examples to understand how memory sort of managed in there. So one side is on the stack side, which I have here in 32-bit integer, and it's equal to 22. So that memory is already allocated in the stack for this integer, for example. Where on the other side, I have this heap, which is a mutable variable. So that's the mut, LET-MUT. It's a mutable vector. And I can actually add to that vector. So again, the size of the memory that will change. So that actually is stored in heap, or it uses heap to store into the stack. So that's kind of how the code works, and the differences between them. We'll talk about how this sort of breaks if you do different things that you might be familiar with in other languages. But that's kind of give you two kind of clear examples of what those look like. So I love, Chris, because you kind of did a quick spoiler of some of the ownership rules. So rule number one, as in Fight Club, like there's one big rule, which is each value has an owner. So there can only be one owner at a time. So I have here this owner. It's a string here, and it says I'm the owner. So this is the owner of that memory or that variable. And there can only be one owner at a time. So I can't actually do the second line of code here where I say, the second owner equals also the owner. This actually will throw an error. In most other languages that you might be familiar with, whether it's the TI-83 plus calculator, so now I see what you mean, or Python or JavaScript, maybe these things won't actually break. And then once the owner is out of scope, so if, let's say in the curly braces here, the value of that is actually dropped. I put 3 P's in this drop out of excitement to emphasize the dropness, I guess, of these things. So the value is dropped. So that's how things get owned or passed around from the ownership side of things. And these are the kind of 3 pillars of Rust ownership that you kind of need to put in your brain. And as you develop and you get errors and things like that, you'll probably go back, and we'll talk about error messaging as well, and probably go back and realize, I'm breaking one of the ownership rules. And that's why. So once you get these down, again, like Chris had mentioned, it gets easier over time.
So Korey, a quick question, and for the benefit of our audience, does everything in Rust have an owner, or is it like stuff that's only on the stack or on the heap? Is there any clarification that we can add? Because I know you're showing me like a string here, right, that I can build over time. But what if I had an integer, right? Would I need to be concerned about owners at that point?
Everything has an owner. That's the rule, Chris. I don't make the rules. I just follow them. So here's some examples of ownership in other languages. So like I said, in JavaScript, I could do this. It'd be completely cool. I have this owner, and then great, I have a string attached to the owner, this variable, and I want to make owner 2, and I want to actually attach it there, and I can print that, and it will be completely cool. JavaScript will never have any issue with this, no problem. But in Rust, we can't do that, as explained, right? Each variable has an owner or thing with that, so you can't actually just assign another variable to that same that data there. So instead, we have a couple other methods that we can do. We can do a cloning. So I have this like, which is like, I messed up here, but this would be like owner, and then I could do owner.clone, and that will make owner2 also the same, or cloning the variable. But it won't be pointing to the same variable. So, in this case of JavaScript, it's actually pointing to the same variable. So maybe if you want to change that, you could do that. So another thing that we have in Rust, it's owner.clone. Thank you, Onko. That is a good shout. So the other example that I have is, another thing that we can do is reference. So we can actually put a reference in here, and this is like the little ampersand. And this is actually then using two variables pointing to the same value. So that's another way around that. But this is the way that Rust handles ownership. So again, you couldn't do what's on the left of JavaScript or even Python, if you will. But you can do this similarly with references, because that's how you're pointing to the same variable, the same piece of data. Cool. So that's ownership. Any questions about ownership, please ping us and we will we'll answer anything there. But we'll go now to tooling and developer experience. Chris, I think you have some thoughts on that.
Yeah, for sure. And so one of the first things that struck me when it came to Rust is the fact that it feels very ready, right? There's a lot of things that is going for Rust, right? So for example, you have the cargo for managing projects, and that thing has a lot of packed features into it, right? Because I'm able to scaffold my projects, I can build my projects, I can test my projects, because guess what? Testing frameworks are built in, right? So just start adding those tests, because I know as developers we don't really love tests, but we kind of need them, right, to pass our code off as it might actually work for these greenfield scenarios. But Cargo can also download libraries. So if some of you, for example, are using package, systems or package managers, this is really what Cargo enables you to do as well, right? So it has this feed, on the web page. I'm forgetting the name right now, but you can definitely ask for whatever packages you want, and via Cargo you can install those and use those in your code, because you don't want to reinvent the wheel. And one of my favorites is Docs Builder, right? Because when it comes to building docs, as developers, we're like, well, I want to code. I don't want to write a bunch of docs. But if it can be generated for you anyway, that's kind of sweet. So some of you who are developing APIs, you might think about Open API standard and using things like Swagger. So I kind of want to put your mindset here in the same place, because with the docs builder, you can just say, look at my code, generate what needs to be generated, and then I can add comments to make that even clearer for myself in the future, or my colleagues on the team, or whoever's going to consume whatever I write, right? So just look at that. Cargo in itself is really, really impressive. And one other thing that I also like about Rust is editor support. I mean, I tend to use more and more Visual Studio Code these days, but Sublime has editor support, Atom, IntelliJ, Eclipse, and so much more. So Korey, do you have any favorites among these editors? It's okay to say something that's not by Microsoft, right?
No, I mean, I'm a VS Code fanboy through and through. I mean, I've definitely started, I think, my early days of working with Sublime, but the VS Code, environment, the extensions we'll talk about also later, I think it just makes things so much easier. And then, you have the Azure integration and stuff. But that's our, VS Code commercial cut.
So one other thing I want to point out about the tooling as well is Rust FMT, right? Because imagine you are a developer, right? And if you ever, as a developer, catch yourself adding a bunch of spaces or changing the formatting manually, stop doing that, right? There are definitely tools out there. Those will do this for you. And I kind of like this for the sake of consistency, right? Because it's so much easier to read the code if everyone formats in the same way, and there's tooling support. So I really love that one. And, there's also Clippy. I don't think that's the Microsoft Clippy, but funnily enough, but it's a tool that's able to recognize what you're trying to write and then helps you write it. So who doesn't love that, right? Any other tools that you might be using, Korey, that I haven't mentioned?
No, I think that's a good cover. I mean, Cargo is, like I said, it's really great. And I think we'll probably talk about crates iOS are seeing what's out there. That's super nice to see as well. And big shout out to Todd, who loves test. Probably one of the few people I know.
You're a
That's
better
good.
man than
That's
me,
good.
Todd.
Yeah, thank you, Todd. Thank you. And then I love this. So Travis had a question around. We had a question around, why is the reason for handling ownership this way? Is it safety? And then one, yes, you are the one. Very, very succinctly puts in first memory safe without needing garbage collection. So that is correct. So that what is kind of why we have the ownership rules. And again, one of the things, the core key features of Rust.
Yeah, I think that's a really good call out, right? Because, because of the ownership model, there is a model in place that, says we're going to give back memory if someone doesn't own it anymore, right? And, the point when someone doesn't own it is when it goes out of scope. So either you're done with, the main function or some sub function, whatever kind of context, right? So handing that memory in a predictable way, I would say. Would you say that's fair,
Yeah.
Korey?
Yeah, I think that's good. It's all about making things sort of predictable or manageable on your side. Cool. Do you have any tooling demo? I put this in, Chris. I'm not sure though if you have anything to demo. We can go on if not.
Yeah, I think we can continue
Cool.
with another slide.
And speaking of error messaging, this is a very good
this
point.
is one of
Thank you,
my
DPS. Rust we
yeah,
trust. We need to
100%.
trust Rust handling our errors. Because,
100%.
like I said, when you start new, you will make a lot of errors. So, Chris, what's with error messaging here in Rust?
I gotta say that this is one of my absolute favorite features about Rust, and I just reflect back on how long I've been in the business, like 15 years plus. And starting out, I think I was starting with C++ and C, and even they have like improved from 15 years back, right? But starting out, there was some horrible error messages. I had no idea what they meant, right? And you were trying to find what place in the code and what should I do instead. And back in those days, internet wasn't as well built out, right? You had to try things, and it took days or weeks sometimes. Stack Overflow wasn't the thing. Just imagine the horror scene, right?
Oh my God, no.
That's
I don't
why
want to.
I know, right? So that's why I'm super happy about Rust and their approach towards error messaging. So what Rust does for you is three things, right? Where it identifies where in the code you fail, but also tell you what's wrong in a very clear and concise manner. And bonus, in some cases, it even tells you how to fix it. So imagine being a beginner developer in Rust, and it just tells you, write this instead of that. Like, it's like having Stack Overflow as a buddy, right, in your editor, or that's what it feels like. It's like, write this instead of that and your code will work. And of course, sometimes you need to look up why this is the better solution, right? But still, Rust has my back and I love it. So maybe we can advance the slide here so I can show some examples. Yeah, so in this first case, I get a lot of help. So what am I trying to do? So we kind of come into the whole ownership bit of things, right? That Korey was introducing to you all. What we have here is a function main and a function log. And what I'm doing is, first off, in the main function, I'm creating a string. And then I'm trying to pass it into a log function, which gives over the ownership, right? Because I'm not passing it as a reference. Had I been passing it as a reference, I would have kept the ownership on my side. But because I'm passing it into the log function as is, that means that log now owns mess. It owns the string that I created previously in the main function. And this becomes a problem, right? Because it's actually telling me, like, wait a minute here. You are trying to borrow a moved value is what it tells me. So a move occurs. So now I'm reading on the right side here. It says a move occurs because S has type string, which does not implement a copy trait. And what this means is that if you look at primitives such as integers and booleans and things, they have something called a trait implemented, which means that they know how to handle a situation where a variable is passed from one side to the next, right? And they use this copy trait to make sure that a copying of the value is happening instead of the actual value. So what it's telling me is that it looks like you're trying to treat me like I was a primitive that has this copy trait, like an integer. But I'm actually an advanced thing, and I live on the stack, so you need to treat me better. That's essentially what the compiler is telling me. So, and it's even pointing out the very place here. So it's telling me the value here is borrowed after move. So it's telling me the why. things go wrong. It's telling me the what, and it's also telling me the where and how to solve it. And on the next slide, I'm actually showing how to solve this, so we can advance there. So what I'm doing here is that I'm not moving it, right? I'm not trying to move it from one place to the next, but I'm instead passing it as a reference. And you can all see here, when I now call the log function, I'm adding this and sign in front of it. And the log function says, well, okay, I get it. I'm not, this is not moved to me, but you know, it's being passed as a reference, and I'm free to print it, free to do whatever, but you're still the owner. Log is not the owner. The main remains to be the owner, right? And so, yeah, so this is one way that you can approach it. And I got here by reading the error message. I was informed by it where the error was, and, you know, potential reasons why this is wrong. But I wanted to show you even one better example, because this is a good one. Like, I don't know if you agree, Korey, that this is pretty good as is, right?
Yeah.
Right. So looking at this second example is even better. And the reason it's better is that it's also telling me exactly what to type. And this is super for me as a beginner, right? So here we're looking at the struct person, and we're looking at the function main. And the first thing this thing tells me when I start to compile is, first off, it's saying, I expected you to have a named lifetime parameter, because what you're trying to do here is to have an and string in your struct. And I'm not really okay with that. That's what the compiler is saying. So it's, and also if you see here on the right, the second thing it's telling me, like, consider introducing a named lifetime parameter. And this one is actually typing out for me exactly what to type. So it says, if you change from and string to and a string, then this will actually compile. That's what it's telling me. It's promising me, just change your code exactly the way I tell you, things will work out, right? And yeah, and in the third bit, it does exactly like the first error message. It's very, very specific on where this error is. And I do believe I have a slide after this one that shows me changing this code. Am I right?
No, I don't think so.
No, so if we go back one slide, but you all see here, based on the second error message from the top, you see what I need to do, right? I just need to go into that struct and just add that, you know, -a thing, and it's going to compile. And this is great for me as a beginner. But of course, as a beginner, I'm thinking, thank you, Rust. Thank you, sweet compiler. But now I need to read up on lifetime. So maybe, Korey, you can explain to people very, very high level, what is a lifetime?
I don't know, Chris. I think you could take this one, actually.
Now, so it's really important when it comes to Rust that, you know, you are dealing with the lifetime. So one of the problems of passing things this way is, I don't think I have a good way of explaining lifetimes right now. So maybe we can just move on and just save that for another presentation. I think we're going to go down a rabbit hole. So.
Yeah, it's a lot of rabbit holes in this presentation that could be easily their own presentations. But we had some questions in the chat.
Yeah.
First one was, is there a newer version of Rust, the possibility to implement polymorphism? I'm not sure as well. Chris, do you know if there's anything like that in any of the? I would say no, but my first.
Yeah, I'm not sure either.
We will check on that. Either. Definitely.
Yeah, definitely keep these questions coming, right? We can definitely, you know, check back.
So I like this one as well. If you have if you're forced to use clone many times, is there a problem, a massive memory for using bigger projects? So a couple of things. So one, I want to give a big shout out to the MVP of the chat, one here, who's answering all the questions when we don't have the time. So really thank you for that. But really spot on answer as well. I mean, so you don't actually need to clone things. You could pass them as references. And one of the things I think a lot of times people ask about this, because when you teach Rust, you always show these like basic examples first, but like people are like, oh, but how does this scale, or what are the bigger problems? But know that even to like Chris's the examples here, there's like error messages. So if you are misusing these techniques, or you pass a reference, or you don't use a reference for some reason, you'll get an error, and you're not, you know, putting this code out in production, and then that's when you get the problems. So before you actually compile, or when you're compiling, this is when you can actually fix these things. And I think, again, that's the real benefits of using Rust, to be honest.
And I would also say, as a general guidance, if you find yourself using clones in a lot of places, you're probably doing it wrong. But I'm not going to say that you're doing it wrong, because it might make sense for your specific case, right? But at least I personally have found myself, if I'm using clone in a lot of cases, I probably shouldn't, right? Because I'm literally saying I'm not okay with having functions that operate on an existing value, but I need my own copy. And if you feel like you have a lot of functions that always operate on their own copy, then I wouldn't call it a smell, but you should still be aware if you find yourself using it too much.
For sure. And then we got Mustafa, who has come in and said polymorphism requires runtime overhead. So Runtime does not have that. So thanks a lot. And yeah, what is the Rust book? We're actually going to talk about that very soon. But yeah, it's kind of the original Rust or Rust documentation, but great resource to start learning Rust. We'll explain a little bit more later too. So the reason I choose programming languages, I don't know if Chris, maybe the same, but I like to look at the community, because if I want to learn a new language, it's normally from the community itself that I do that. So like, if there's a vibrant community that's making educational material, something like this, or things like that, it's much easier to learn, and you can find help from people. And I think the Rust community is pretty special that way. So there is the Rust user forum on the Rustlang site. There's also an internal forum, so you can actually see the discussions around developing the Rust language and contribute directly in there, which I think is pretty unique for a lot of different languages there. And there's also the Rust Discord, which is a very vibrant. You can see there's 47,000 members, and a very vibrant community to join. If you have any questions, people are very open to that. You can see also the questions are even in the forum, so you don't have to just rely on Stack Overflow. Like, you can ask some pretty in-depth questions on those Rust forums and get good answers even from the contributing team. But speaking, and then also with Rust community, I really love, I don't know if you've seen these pages, Chris, but they're like Are We pages. I don't know what else to call them, but Rust is trying to do a lot, right? They're trying to do web, we're trying to do GUI, we're trying to do gaming, which we'll talk about. And, it's a lot of things are in development or not, still kind of maturing. And so there's things like Are We Web Yet, which is talking about Rust development for web, even front-end web development. There's GUI, as well as bringing developing GUIs. We'll talk about gaming, but there's an Are We Game Yet as well. So there's tons of these sites. I don't know how many they are. I don't know if there's one site that has a collection. If you do know, put it in the chat. But there's all these Are We sites, and they give you one exactly where it is. So Are We Web Yet? Yes, it's freaking fast. But then on the GUI side, it's pretty honest. It's not like people are saying, yeah, we could do that. The roots aren't deep, but the seeds are planted, which is pretty artistic too. So that's the Rust community in a nutshell. And yeah, we'll talk about Bevy too as well. See that in the chat. But talking about community, so everyone here in the chat here is able to also continue their discussion and questions to us, and the discussion as well. We have a new kind of Reactor tech community going here, and I'll put this in the chat. But basically, I will put all of the links that we have shared here, and all the things that we talked about, the different libraries and stuff, on this page, so you can see that now. And if you have any questions, or you want to just help people or meet other people who are learning Rust, you can feel free to go comment and discuss all of these things. So that's what the page looks like. You can do the QR code or the link as well. So some of the great things you can make with Rust. So thank you. As far as talking about gaming, we talked about some of that, and we talked about the community being honest with what you can do with Rust. So the first thing you would do is we can make CLI apps, right, Chris?
Yeah, for sure. I mean, I think for most languages that I'm starting with, I think I'm starting with a CLI app and just try to understand what that experience is like, right? And I think, Korey, you mentioned that there are crates, right? And crates are libraries that you can use, and you can use cargo to download them, right? So there are definitely a lot of really fun CLI crates that can help you, like everything from processing command line parameters to adding color and a lot of other fun things, right? So when it comes to high-level CLI apps, we need to think about when do we use them, right? They're very popular to use, for example, for CI/CD pipelines, because you're passing in some argument, you do some kind of processing, and output is maybe some artifact or some kind of reporting, right? Or you're just trying to batch process things. The point is, you usually don't need a user to interact with these, and you don't need a fancy graphical user interface, right? You don't need a GUI. But in some cases, you do. And in some cases, you have that human, that poor human, looking at that black terminal and just wishing that they are being considered as we design our CLI app, right? So they expect to have friendly messages back, maybe something in color to highlight importance and things like that. So, and the good news here is that Rust has all these things, right? Everything from processing command line parameters to uh, coloration and much, much more. So maybe we can advance the slide one notch. Right. So with the, and one more, I believe I have the code here for CLI app demo. This is a very popular exercise to do in a lot of languages. This is about guessing a number, and this is just me showing you how much code is actually required to get that done. So what I'm doing here is, first off, I create a looping construct. And I have this looping construct because I assume that people will guess n number of times before they get it correctly. And as you might see in the code here, about halfway, I am talking to something called the standard input and read line. So via read line, I'm able to read whatever the user is typing, and then they hit the enter key. At this point, I'm storing this into string variable. And after I get that into a string variable, I need to parse it into an integer. So I use this parse function, and I get a result back, and I need to unwrap that result. So I'm dealing with the actual value I'm getting. And then I'm doing something really, really cool. I am dealing with these comparisons, right? So I'm using this comparison called ordering, and it's pretty sweet because it lets me do a comparison and see if something is larger, smaller than, or equal to. And this is Rust being really elegant, right? That it has these kind of enums defined for you. So you don't have to like say, well, 0 here is the same thing as equal, -1 is less than, and +1 is, larger than. So instead, Rust has these really sweet types in the language itself and is ready for me to just use ordering. And you see how elegant the code becomes, right? I can just say your number is too low, or your number is too high, or your number is equal. So as you program more and more in Rust, you will discover how Rust have most of these enums defined for you. So if you feel yourself defining an enum, you should probably have a look at Rust and see someone had to think about that. I don't know. Did you do that in the beginning, Korey? Did you invent your own enums and then discover later that Rust actually had it? Or
Yeah, I mean, I think it happens with a lot of Rust. Like you just assume things built in, and then you look at others' code, or you like are searching for something, and then like you're like, wow, this is all there. And I think that's like one of the big things. Like I think I find surprising so much about the language is that there's so much built in. And I think I love this example because like if you have never seen any Rust code, you could probably just look at this and almost understand 98% of what's going on. I think fairly well, just from looking at some of this, especially if you have already like a programming background in something other language. So that's just again another, like you said, elegant part of with the language, I think.
yeah, exactly. So one thing I want to call out is that when I call this readline method, right, to collect the user's guess for what this number should be, note how I use and mute. And this is a mutable reference, which means that the readline function will actually change the guess variable. So it will store a value to it. So the only way for it to be able to change this variable and what it points to is if I pass something that's mutable and a reference. Because if I don't, in the first place, don't pass a reference, then it's going to be angry at me for that other error that we saw before about, hey, you're trying to do a move here and you shouldn't, right? But I also need to make it sure that the reference is mutable itself, so readline can do its business and assign the user's guess to my guess variable. But another thing I want to call out is the fact that I think it's really elegant how Rust can use this match construct. And instead of us writing a bunch of switch case or if and if else, I can just have this match and compare things. And you can definitely see that in the larger part of the Rust language, how match is kind of the preferred way to do anything, like anything from trying to open a file to doing a web request. You're going to see matches everywhere. So don't be afraid if you see those. Those are just for elegance. And just imagine having to rewrite this switch case example into, having to have a switch case and not having the match. It's going to be more verbose, right? There's a few more characters that you need to type. So be really grateful that Rust is kind of standardizing almost on using match constructs. Would you agree on that, Korey?
Yeah, I think this is very well put with the code. And there was some question from around ordering because of the necessary default. And our MVP of this stream, of course, one has come in, has also answered that question. One, if you could find me on Twitter or LinkedIn after this, I would love to have you on a stream because you're very nice to share all of your knowledge and help us out. We don't have to answer all the questions, especially with helping the chat.
Yes, and I would like to add to that response because yes, 100% true. Rust actually helps you in the compiler. So if I hadn't dealt with the case ordering equal, it would actually have failed compilation, right? Because here's the thing also when it comes to match expressions, there is this underscore that I can use to catch all the other cases, right? So if I have 4 possible cases and I only cover 3 of them in code, I'm going to get a compilation error unless I use this underscore to say like, hey, I have a catch all here. So I love the fact that Rust enforces me to not leave out certain cases. So if I in the future were to extend upon an enum and just add a case, I would actually make sure that other code that I've written that says, well, in the past, you only dealt with 3 cases in that enum, but now you have 4. So for that reason, code that you've written in the past is now going to fail compilation because there's a new case and you need to handle that. Unless, of course, you have this catch-all underscore.
Very good point.
I just wanted to add to what Korey is saying. You guys are MVPs. Thank you so much for helping your fellow Rust coders. And about this image, this is, I didn't mention this in the CLI example, but I did add a library or a crate here called color. And it provided colors because I love myself some colors in the terminal, right?
Especially in the CLI, you need a bit of CLI.
I know, right? So I'm adding green to symbolize that here's a success. I'm using blue for information. You could use red for warnings or errors, right? But just be wary of your users. So this is just a general tip when you build CLI apps. Please give them some love. There are real users who's going to use your program. They're going to really appreciate the fact that you put down the time. And there are a number of crates. I think there are 3 or 4 crates at least that you could be using to put some color into your terminal apps. Yeah, I think we can move on unless someone has a question on CLI.
No, there was a nice comment. First intro to Rust. So we have a convert. So now our job is done. We've converted at least one person to Rust. So awesome. It's only going to be all uphill from here. And yeah. So I meant to have a title slide here, but now we're going to talk about the actual great things you could build with Rust. Because a lot of times, again, you hear the hype and then you're like, well, great, I built a CLI app. Like, what? That's not that cool. But there's some other great things you can do with Rust. So the other one is WebAssembly or WASM. If you're not familiar with WASM, just to give you an understanding of what it is, it basically allows you to build web applications in non-JS languages. So your Python, your C++, Rust for this example. And it's meant to be a JS complement and not a JS replacement. And I put ... yet because if you're like a hardcore Rustican, you might want to like use a library or create like Yex, Y-E-X, that can do actual front-end development. But a lot of people are really pointing to WASM as far as just like in Rust, working with the server side of things. So, again, you could do like your standard JavaScript frameworks with front-end UI stuff and then leave Rust for the back-end stuff. To you, I think it's better place on the back end, as my personal opinion. Really nice about WASM is actually it runs on all modern web browsers. So I think when you get into web development, like you're always skeptical when you're like, oh, this is a new concept, and then it's like, oh yeah, but it only works on like the newest version of Chrome, the newest version of like Firefox, but that's it. And like the users that you're developing for don't use that browser, so it's super annoying. But this actually works on all modern browsers. And the other thing is like, oh, great, I can do web applications. I could do that in like Django. Like that's not exciting. But this actually delivers near native performance for the language. So when we talk about Rust, like the biggest thing is performance-wise. So now we're developing applications using Rust. So now we have high performant web applications that are, if you look at the benchmarks, quite significantly higher than what you will get from your standard JavaScript frameworks, for example. And just to show you why I think Rust is super important in this WASM world, again, you can use any language and work for almost every language now, is that there's actually been a quite amount of activity and investment in the community or development, which makes it much easier for you as another developer to work with. So if you look at the state of WASM, which is this, you can go to this link. you can see that one is primarily used for web development in Rust and also serverless. So shout out to anyone who's doing serverless and it wants to learn using Wasm. You can do that, and it's probably going to, if I have a prediction instead of that, and it get a lot more of a bigger performance boost. Continues to grow year on year. So again, more and more people, more and more support for the community. How Wasm actually works is you actually are pre-compiling the language before it actually hits sort of the machine code or the where things work. Basically, in this case, we're talking about Rust and the compiler. So you're actually pointing your Rust code to the Wasm compiler. And then it has, instead of designing for a specific machine in mind, so like x86 or ARM, I think we lost each other, or hopefully, if you're still on the stream, let us know. The joys of the internet. Oh no, yeah, this is why we need Wasm, everybody. I can get better performance on my stream. Cool. So we're back. So talking about Wasm, basically, brief. You're pointing to great. Everyone's still here. Pointing to the compiler, you're pre-compiling instead of just-in-time compiling, which I think a lot of the other other languages are doing. So again, you're really saving a lot of getting more efficiency from that side. And then there's different different sort of cargo packages as well to use within Rust. So there's Wasm pack, which basically you can use Rust WebAssembly and build a node package in itself, publish it to the npm, and then use it just like a package node package would do if you're familiar with Node or JavaScript. We also have Wasm bindgen, which is sort of the bridge between JavaScript and Rust. So you can use your JavaScript to point to a Rust API and also use a Rust function to wait or monitor for JavaScript exceptions. So there's a quick example here. I won't go too much into detail, but this is actually like Rust code, but it's also using the alert, like the JavaScript alert, to point to that. And we talk about Wasm a lot around web development, but you can actually use another package called Wasm Time, which is using run Wasm outside of the web. And I think from the last presentations, Wasm is actually some of the core contributors are based in Sweden. So happy to do that. And exactly to Kevin's point, there's mscriptum for C, and this is very similar to that for Rust. But this is Wasm Time, and it uses for like IoT devices, servers, desktop apps. We can also use Wasm there and get the performance. Another point is gaming. There was a question around my opinions on Bevy, or what our thoughts were on Bevy. So Bevy is another is a game engine built with Rust, and also GGEs. One is Bevy can do 3D and 2D game rendering and development, and GGEs just, I believe, only does 2D games at the moment. I have not worked with any of these, unfortunately. I'm not a game developer. I would love to be one day, but I know they're growing in popularity. GGEs is like good game easy, so I'm assuming it's pretty easy and to learn. There's good materials on there, but just to point out to people, because they might not know, that you can also do game development with Rust. So another exciting and more visual thing to do. This was an interesting one that this got designed. REST APIs, Chris. How about this? What can you do with that?
Yeah. Thank you for that, Korey. Yeah. So one of the first things I did with Rust, and this is my personal experience, is to build an API, right? Because we all want high-performing languages, regardless of whether it's C++ or Go or Rust. And Rust has some really good web frameworks. Everything from normal web frameworks serving various static resources to more dedicated ones where you build an API. So in this case, I'm showing you something called Warp. Are you able to advance the slide so we see a visual callout? Yeah, great. Thank you. Yeah, so in this case, we're using Warp, right? And Warp is a crate that you can download via Cargo and use in your application. If we advance it one more step. Yeah, great. So here we're able to see how Warp actually sets up a route. So what it's saying here is API/HTTP example. So this is one way that you can build up your path. And once you build up your path to say like, okay, I'm going to handle this specific route, then the rest of the code is actually doing things with query parameter. If we advance it one more time. Great. So in this case, you can see here, right after I set up my route, I'm able to parse a query parameter, from my URL, and I'm able to say, okay, you're providing name, so I'm going to do something with name. In this case, I'm going to use, and here we see again how Rust is using these enums to actually, instead of using a switch case, is able to do this matcher-like behavior and say like, I got a value, that's fantastic. I got a value on my query parameter, and I'm able to respond in the body and say like, hey, okay, hey Korey or hey Chris, whatever I populate that name variable with, right? Or if I don't get any name parameter or it's not filled in, then it's going to match the none case, in which case I'm just saying, well, you need to actually provide the name query parameter for this function to work. So that's really one flavor of how you can be building a web API. And you can also see here how I am making it start on port 3000 if you advance the code a little bit. But yeah, here is another flavor, right? So in our first flavor, we saw Warp. It had a very specific builder-like pattern of saying, I'm going to set up a route. Once I set up a route, then I'm going to process your request with a response handler. In this case, we're using a very popular web framework called Rocket. And I think I've seen this on every single blog post out there. I don't know if you see that too, Korey, if you're looking for these kind of. Yeah, so Rocket is another very popular flavor. It does it slightly differently. So instead of using that builder pattern to set up and match your route with a response handler, it instead relies on these traits or decorators on top of your function. So you can see, for example, in the update function in this example, how it says, well, I'm going to match a wildcard with ID, and I'm going to grab some data that I think you're also passing from the body. And I also think that body data is JSON. So I'm going to actually parse that for you. So just imagine setting up the route and getting a nicely parsed JSON data that you can just work with straight away. And in this specific example, I go into my database and just say straight on, yeah, I'm going to insert this content I'm getting from the body. But as professional developers, we know that we probably need to add some validation here, right? Because this seems a bit scary. Someone just posted something on the body. So yeah. But yeah, Rocket is really nice, and I think this matches with my at least inner model of how you could be, setting up a route and setting up a response handler. But you do you, right? If you feel like you want to use the builder pattern of Warp to set up and build up a path, or if you want to use Rocket, I don't think you can go wrong with either, because they're pretty popular, both of them, and they have a very active ecosystem. But yeah, so just to go back to what Korey was saying here initially, there's so many different things that you can build with Rust, right? Games, web APIs, CLIs, working with Wasim to boost those libraries that you have, or maybe build the next Unreal Engine. I don't know. You use Rust for whatever you want, but it's super fast and it's a fantastic choice. I can't remember if I had any slides after this one, but
I don't know. But I like this comment from Kevin. It almost feels like Express. I mean, I think some Rust community will have a heart attack that you wrote that, but it is like Express, but it's so much faster. That's the quick answer of all of these things. But yeah, I think it's very familiar to some different languages as well.
And one thing that could be said about Express, though, is that it's very easy for most people to get started with Express. And you might have your religion, how you want your library or framework to look like, right? But if it's easy to look at, a lot of people are going to use it. And just to reinforce what you're saying here, Korey, you got the speed of Rust behind this. So simple to look at, super fast. I mean, win-win, right?
Win-win. Let's see. So yeah, you have also the Azure page as well there.
Yeah, so I think when I designed this slide, I remember that I actually work for Microsoft. So there is a way to use Rust at Microsoft, and this is how, right? This is one of the more obvious options. Some of you might be authoring serverless functions in some cloud. We don't judge. We're not here to judge. If you're using Microsoft, you are probably using Azure Functions. If you are, the good news here, if you also love Rust, you can use something called custom handlers. what custom handlers are is that they are a worker that allows you to use a binary, right? So if you compile a binary in Rust, you're going to be able to point to that binary in a JSON file and say, here's my program. It's using Warp or it's using whatever web framework to serve HTTP primitives. And when I say HTTP primitives, I mean you have defined a set of routes and a set of responses, and you can just tuck that into Azure Functions like you're used to if you're using some other language to do that. So this is a great tutorial that will show you the capabilities of Rust. I believe it's using some kind of queue in this very example, but it does show you all the way how to work with Azure Functions and how to set things up. But yeah, pick your web framework, compile that, tuck that into Azure Functions, and off you go. There was a comment there. I think I missed it.
It was Bring on the Blue, Azure for the win. This
All right.
Microsoft love there, so that's nice to see. And I will include that link, shorter link, so you don't have to like try to remember this link in the community page I shared. So that'll be in there for you to run that things. So now that we talked about great things that you can make with Rust, like how do you actually get started with making all these great things? So what was already mentioned is the Rust book. This is the URL. Again, it'll be also in the bookmark page that I made for the community site. But I mean, Chris, I know you write books, so you're probably gonna like not love to hear this, but I haven't read a programming book in years. Like, I think this is so much tutorials and things I could pull down, and like just going to the docs, for example, is another way to learn. But the Rust book, I think, has probably been one of the most approachable experiences to actually learning a language via reading a book, or in this case, it's kind of in documentation format. But it's super approachable because it explains many of the concepts that we talked about here, and even like with good analogies, simplicity, examples. So really shout out to everyone who has contributed to the Rust book. And it's, I think, a really fundamental place to start. And like, even if you're like, oh yeah, I don't really read books when I learn languages or whatever, like I'm a documentation person, I think you should definitely try to go through this book as long as possible, because it's going to give you a lot of the fundamental knowledge that you'll need when you're working on your Rust journey.
Yeah, I can only plus one what you were saying, Korey. I mean, I think I've read that book many, many times. And even if you don't want to read it in one go, just look at a specific concept, because it does a fantastic job of explaining, for example, the ownership model and things like that. So yeah, definitely
100%.
have a look.
But another way you can do, we talked about VS Code. We'll talk about it a little bit more later too. But if you want to even try some of the example code that we showed here, is you can do this Rust Playground, which you can write and run the code, and you can get some quick results as far as you learning things. So especially if you use the Rust book and the Playground next to each other, I think that's like a thing, like a nice two screen is perfect for learning Rust and getting very hands-on there. And people not reading programming books, I like that, is the reason why we need memory state programming languages. True. That's a true statement. I'll give you that one. Cool. And then, like I said, we have this Microsoft Learn module, create your first run program. And it's actually part of a whole series. I think it's like 5 hours long. So really another nice way to get started, and really building your first run program and like getting results. I think it's a big time, because we're not talking about like, front end development in this case, where you put on an HTML and JavaScript page and you can instantly see where things are, how things are working. It takes some time to get there with Rust, I think. So it's great to get have a good structured way to learn.
Just to add shortly to what you were saying there, I think we actually have a learning path, right? So I think you're pointing to the first module and a longer path. So there are several hours of learning with Rust on Microsoft Learn. So
yeah, it's like 5 hours. So I mean, but the road, what is it? The path to 1,000 steps begin with one step or something. So start there and build your way up. I definitely ruined that whole analogy. Let me know in the chat what the code is. Cool. And then setting up the VS Code extension. Do you want to talk about that a bit, Chris?
Yeah, so there's definitely a really good language server for Rust that you can set up inside of Visual Studio Code. So yeah, I would just type Rust. I think it's from Microsoft even. And yeah, you install that thing. And once you do that, it will give you all the different, what do you call those, snippets and every kind of comment of, are you doing this correctly or not correctly? for sure, before you try to compile, the editor will have for sure told you, all the things you've done wrong, if you've done any wrong, or just be that helper on the way, right? So I would definitely recommend installing that extension because it will boost your overall experience. And I believe the formatting is in there as well. I think with the extension.
Yeah.
So yeah,
and I put a link to some of the docs on the browser, the community page. So actually setting up all of the things. We won't have time to do a whole demo here, but you can see that there. I like that one.
What Todd is saying.
Yeah. So this is great. So this nice segue. So this segment here, this workshop is a part of a series, which is again a journey through Rust. Which thank you, Juan. You've really solved everything today. So he actually fixed my quote. It's a journey of 1,000 miles begins with a single step. So this is helping everyone take their single steps into Rust. So we have this series. We had another one called Getting Started with Rust Projects. So 2 people that were doing Rust development like professionally. They showed their projects. That was like 2 weeks ago. We have some upcoming sessions coming up. One is like called Getting Started with Your First Rust Job. So Marcus, he actually recently transitioned from Java development to Rust as a full-time developer. So maybe you have been really inspired with everything that we have said to you today, and you want to actually start working with this full-time, or maybe you're like already on your journey for that. You can join that session, and Marcus can answer any questions you have around actually going like professional Rust go to the professional league, because we're just amateurs here, Chris and I guess. And then we have another one called Getting Started with Rust, Understanding Compile Errors. So we talked about Rust and error messaging and how that's super helpful. But sometimes we showed some clear examples of like do this, move that. And sometimes those are good suggestions, but there's actually maybe other ways you can fix your errors, or even approaches that way you don't have those clear, like just delete this kind of thing. So we're going to walk through like a step-by-step level with handling how to handle compile Rust errors from like easiest to the hardest. So it should be a good session. Again, if you start with some of the Rust sessions that we are educational material, like the book, the learn, and then you get ready to do something like this. That's going to be on November 16th, and all the updates and that will be posted on our meetup group, which is aka.ms suite up. So you can go there for any of those information. And then we tried to answer all of the questions here, almost all of them, but you had tons of questions. So unfortunately, we can't answer all of them. And I really love, big shout out to one, but like just to show like the power up community and like being able to have multiple people answer questions is a great way to learn and being in like a learning community and learning space. So we're really using this tech communities, which again, that's the link there, to be a place where everyone can come discuss their questions that they're having with Rust, and not only like rely on Chris, myself, and other people at Microsoft to help them with Rust questions, but to help yourselves, to find people that are learning maybe in the same space, maybe they're learning the same language that you have before, like you find 2 Python programmers or maybe 2 Pascal developers. I don't know, maybe that's possible. There's 2 out there. And then you can learn together. So really use this space to connect there. I'll hang out there for a little bit as well to answer any immediate questions. But it's going to be a lively space. And if you could keep with us on this kind of Getting Started with Rust series, this will continue to update, and we'll continue to use this for sharing Rust resources. And if you also have Rust resources that you'd like to share, feel free to drop them in that discussion as well. And yeah, there's 2. Oh no, 1. You've done Pascal as well. You've done it all. Okay, well, there's 2 people here and done Pascal, so you can connect. Cool. But good luck, everyone. That was an untimed space in my space thing there. I turned to handle Korey space. Chris, I don't know I was going to add you, but then you never sent me your details.
Yeah. Apologies on that. Chris _Noring on Twitter. That's the best way to find me. My IMs are open, so definitely bug me. I'm happy to try to answer the question or just route them to the other godlike creatures we have here on Microsoft on Rust. And I think that came from you, Korey. We got some really good Rust developers at Microsoft. So ask us hard questions as you want. We'll make sure that those hit a target that will respond back to you.
Yep. And yeah, I don't know where one is going to be followed at, but one, if you could connect with me as well, would love to have you on as far as another workshop or something. But yeah, very nice. Thank you for everyone for joining. Like I said, I'll hop into the communities page on the Rust Discusser. That's where you can continue the discussion. Any questions you have, share some resources, connect with everyone. But yeah, thanks everyone. Hopefully you pulled some things in. Hopefully we will also, convert some people to Rust now.
For sure. And I think from the both of us, in Rust we trust, right?
In Rust we trust. Yes. I wish I could find that quickly, but I can't. But yes, see you everyone. Bye.
See you.